This workshop is about digital preservation, which means documenting and preserving what we can already see with our naked eyes in documents, photos and film. A scientist will say this information lies in the visible range of the electromagnetic spectrum. This talk is about the information that could be found in the ultraviolet and infrared regions of the spectrum. This 14th century icon is covered by a thick dirt layer. The infrared photo reveals the drapery, the cross and the curl's hair. This wall painting seems intact, but the infrared false color photo reveals that the right part of the sky was retouched. The painting has a print on the frame. It can be probably read only in the ultraviolet photo. This canvas doesn't seem to bear any information, but the infrared photo reveals the stamp of the manufacturer. Cultural heritage science is the academic discipline that studies and develops these and other scientific methods to reveal hidden information. Cultural heritage science open source is an effort to disseminate this knowledge outside academia and directly to professionals involved in cultural heritage. I like to read its acronym CHSOS, such as Cultural Heritage SOS, because of the Mona Lisa syndrome. Scientific research is attracted by popular artworks in prestigious museums because they benefit from media coverage and substantial funding. The more the media attention, the more the funding and the research on these important artworks. There is nothing wrong to complain about the Mona Lisa phenomenon. The only issue that I see is that this research developed to serve this high-end sector, it doesn't necessarily translate into a benefit for the vast and larger community of cultural heritage institutions which don't have access to comparable resources. I admit, I was myself looking for glory, serving in celebrated projects with plenty of media coverage. I was working with sophisticated equipment in big museums. I was using fancy facilities and, in general, I was enjoying myself playing with scientific toys. Then, 2 years ago, I heard the SOS call and I started CHSOS. Its mission is to promote innovative, affordable and sustainable technologies for art examination and documentation, in order to serve the largest community of medium and small institutions and museums. This goal is achieved by 2 methods: development of these technologies and their dissemination through 4 services. My hometown in Sicily is famous as the location of many Sicilian card painters. This Sicilian cardboard is dated 1920s and it belongs to Master Domenico Di Mauro, currently 101 years old and still painting. This picture was taken just 2 months ago. Looking at the detail, the infrared reflectography image shows the underdrawing the painter laid to set the frame. Unfortunately, infrared reflectography cameras have a very small imaging detector. To document all the scene, it is necessary to shoot and mosaic a grid of images. This job is done by infrared scanners which are sold to museums, but they are very expensive and bulky. CHSOS has developed a method which uses a panoramic photographic head and a commercial stitching software. This system produces comparable results at less than 1/3 of the cost. Once the technology has been developed, the next step is to disseminate it through 4 services: publications, rigorously on open access journals, posts on the website chsopensource.org, and training programs to professionals which want to have hands-on practice with these methods. These trainings are delivered in Sicily in the CHSOS studio, working and studying Sicilian artworks. Trainings can also be provided abroad, such as this one for the National Institute for Cultural Heritage in Ecuador, who wanted to develop their own imaging laboratory. This is an example of a 5 days intensive training program for an art diagnostic company. First day knowing the equipment, second day practicing on site, third day the students try to carry on the documentation on their own, fourth day the students mastered the methods, fifth day was dedicated to learn the 3D photo modeling. The last service is on-site art examination for museums which want to have their collection examined. The equipment fits a checked luggage and a carry-on. The idea is to have a mobile and what I like to say Ryanair-proof traveling equipment to set an imaging studio on-site. The luggage contains tools, the panoramic head, the lamps, and everything to take high-resolution imaging in the visible, in the ultraviolet, and in the infrared. And it also comprises infrared reflectography camera and the tools for reflectance transformation imaging. We just saw the multispectral imaging equipment. It is implemented with a modified digital camera and a set of only 4 filters. Even if very affordable, this equipment can help to find out plenty of hidden information thanks to the 7 technical photos, each one providing different insights. As usual, there were posts and publications on these methods. CHSOS is collaborating with Giovanni Landi, an engineer who developed an app to provide augmented reality use of these multispectral images. The app identifies the painting through the iPad camera and then dynamically follows the painting and overlaps the multispectral images. Here we see the retouches in cadmium red thanks to the infrared fluorescence image. RTI, reflectance transformation imaging, has also been promoted by CHSOS because it requires basic equipment and it is very versatile. This video shows its application to document historical graffiti in the catacombs of Syracuse, Sicily. As usual, there were posts on the blog and publications. Reflectance spectroscopy was also promoted through posts and publications, because this method can be now implemented with miniaturized spectrometer and therefore it is very portable, other than being affordable, sturdy and lightweight. The grey box on the top right is the miniaturized spectrometer. A fiber optics probe and a halogen light source complete the system. Reflectance spectra allow to identify pigments because they have characterizing features. And this is a smaller probe which is used to analyze delicate artworks such as this painting, and this is the live acquisition of the spectrum of vermilion. Imaging spectroscopy has been promoted because of its portability and thanks to a collaboration with Marco Snickers from Pixeltech. The spectral camera mounts interferential filters which can be manually changed on its filter wheel, and the camera acquires 8 spectral images. This photo gives an idea why portability is so essential in art conservation. It was easy to bring the lightweight spectral camera up to the last floor of this huge scaffolding and examine the frescoes of the ceiling. This is a mock-up of Renaissance painting. On the gesso ground, an underdrawing and a coping grid were laid. The drawing was then painted over with Renaissance and modern pigments in order to simulate a painting that has been heavily restored and retouched. The sky was painted partly in modern synthetic ultramarine and partly in original azurite. Yellow ochre was used for the hair, and 3 different green pigments were applied on the background: verdigris, malachite and modern chrome green. The shirt was painted with red ochre, but its right sleeve with modern cadmium red. A jewel in modern titanium white was also added. The skirt was painted with synthetic ultramarine and eventually the flesh with a mixture of lead white and red ochre. This photo shows the final product, which obviously doesn't claim artistic ambitions. The first spectral image at 800 nanometer shows that the cadmium red of the sleeve is brighter than the rest of the shirt painted with red ochre. We observe the same situation until the spectral image at 620 nanometer. At this wavelength, the reflectance of the 2 pigments is comparable, but at 578 nanometer, cadmium red turns darker than red ochre, and on the other images they become equally dark. There is software that can analyze pixel by pixel all of these spectral images and group together pixels that have the same reflectance. This software made this map, and it was able to distinguish the 2 blue pigments, the 3 greens, and was able to identify the cadmium red sleeve. I added the adjective versatile to describe the spectral camera. We explore now how this camera can be used to examine objects of very different sizes. A large panel painting can be examined with sufficient resolution, mounting the camera on a panoramic head. The painting is documented in 4 sections, and the images are then stitched together to provide 12 final high-resolution spectral images. We now move toward small objects. A postage stamp can be documented with a macro lens. The images at 578 and 620 nanometer show that the ink has a sharp change of reflectance at about 600 nanometer. We can make a graph of the values of the reflectance for each filter, and we obtain a reconstructed reflectance spectrum in dotted line, and we can compare it with the reference reflectance spectrum of Madder Lake, known to be a component of postage stamp inks. We now want to look at the chip of paint that was embedded in a synthetic resin to make a cross-section sample, and the spectral camera was mounted on a stereo microscope. We want to reconstruct from these images the reflectance spectrum of the red ground dotted line, and we see that it compares well with the reference reflectance spectrum of red ochre. We conclude with the smallest colored object that we can imagine, a single grain of pigment mounted on a microscope slide. The spectral camera was coupled to a microscope. The spectral images of a grain of smolt shows that it has high reflectance in the 400 nanometer range, while its reflectance is low between 500 and 600 nanometer. Reflectance rises again in the 717 nanometer range. Its reconstructed spectrum, dotted line, significantly overlaps the reference reflectance spectrum of smolt. A grain of azurite shows to reflect light just in the 400-500 nanometer range, and its reconstructed reflectance spectrum overlaps with the azurite reference spectrum. In conclusion, in 2 years, CHSOS has promoted 4 methods: panoramic imaging, multispectral imaging, RTI and imaging spectroscopy. CHSOS had contacts in 14 countries, providing on-site art examination, training programs abroad, training programs in Sicily, and has been invited as guest speaker in 3 countries to tell the cultural heritage SOS adventure. Thank you.